students, welcome back to mathematics class. And coming to trigonometric ratios. In this video we are going to discuss few more important problems, especially from subjective task 2. I hope you all ready for that. So let us start subjective task 2. So coming to question number 3. Question number 3. If tan 20 degrees is equals to lambda, then show that tan 610 degrees plus tan 700 degrees divided by tan 560 degrees minus tan 470 degrees is equals to 1 minus lambda square by 1 plus lambda square. My dear, even in the last video also we did one problem related to this model. So now, before entering into LHS, let us simplify and find out the individual values of each and every tan some angle, that is tan 610, tan 700, tan 560 and tan 470. So coming to first one, we want what is the value of tan 610, that too in terms of lambda. Okay. So now 610, I just want you to write 2 into 360 minus 110. Can I write like this? 2 into 360, 720 minus 110, which is 610. So now you know, basically because of 360, tan remains tan itself. Okay, that too, this is even multiple of pi by 2. Don't worry. So now this is just like you can treat it as a 360 minus theta. Because of 2 is even, no need to consider entirely. Just think that this is 360 minus theta. You know which quadrant? 360 minus theta belongs to fourth quadrant. In fourth quadrant, tan is negative. That is why this entire value is equals to minus tan 110 degrees. Okay. So once again, because of 180 and 360, there is no change of trigonometric ratio. That's why tan remains as tan itself. And moreover, now this is, you can think just like a fourth quadrant, this is like 360 minus theta. In fourth quadrant, only cos and secant are positive. Rest of them are negative. So anyhow, here tan is negative. So now this is equals to minus tan 110. But you know, my dear, we know only tan 20 as lambda. So still 110 should be expressed in terms of 20. Hence 110, I want to write it as 90 plus 20. Now because of 90, tan changes into cot. Okay. And moreover, this is now 90 plus theta, which is second quadrant. In second quadrant, tan negative. Already there is a minus. So minus of minus will be plus. Finally, which is cot 20. And that too, you know, tan 20 is lambda. Then cot 20, I can write it as 1 by tan 20. That is 1 by lambda. 1 by lambda. This value is 1 by lambda. Similarly, let us find out tan 700 value. So 700, I just want to write like this. Because 2 into 360, 720 minus 20, 700. So once again, because of 360 and that too even multiple of 360, nothing but even multiple of pi by 2 finally. So tan remains tan, and moreover because of 360 minus theta, fourth quadrant, tan is expressed as negative. So minus tan 20, this is, I can write it as minus lambda. Right? So coming to next value, tan 560. Now 560 I want to express as 360 plus 200. Now because of 360, tan itself, no change. And now you know, my dear, this is which quadrant? This is in the form of 360 plus theta. This is just like 360 plus theta. And above things are 360 minus thetas. So these are fourth quadrant. But this is now first quadrant, 360 plus theta. All are positive. That's why this is equals to tan 200. But finally we need to express in terms of 20, no? So now 200 I want to express as 180 plus 20. Now once again, two questions you need to put, my dear, regarding these allied angles. One is there is a change in the trigonometric ratio or not, and next one is about its sign. I mean whether it is plus or minus. Now because of 180, tan remains tan, and coming to 180 plus theta, this is like 180 plus theta, which is third quadrant. Anyhow in third quadrant tan and cot are positive. So this is equals to plus tan 20, which is lambda. Coming to 470 can be expressed as 360 plus 110. Now once again, because of 360 there is no change in the ratio, that is tan itself, and 360 plus theta is first quadrant, no? So first quadrant all are positive, and tan theta, in the place of theta we had 110. Okay, now coming to 110, once again we can write it as 90 plus 20. Finally you see, my dear, all outputs are in terms of 20, because we know the tan 20 as lambda. That is the only logic here. Now once again, because of tan 90, tan changes into cot and theta is nothing but 20. Now question number 2, whether it is positive or negative. Can you think now 90 plus 20 is in which quadrant? So 90 plus 20, which is 90 plus theta, of course second quadrant. So once again tan negative. So that's why minus. And you know this value is minus 1 by lambda. So this is the first step, my dear. Individually each and every value of tan must be expressed in terms of lambda. Now can go for LHS. So what we had, first of all, tan 610. What is tan 610 value? 1 by lambda plus tan 700 is nothing but minus lambda, of course, minus lambda, and tan 560 is lambda, and what about 470 minus of minus 1 by lambda. So now this is, if you go for cross multiplication, 1 minus lambda square by lambda, okay, and whole divided by lambda square plus 1 by lambda. So denominators are getting cancelled. Therefore, which is equals to 1 minus lambda square by 1 plus lambda square, which is very important model. Every year, any competitive examination, you can expect at least one question, right? Coming to the problem number 1. So once read the question, everybody. If alpha and beta are complementary angles such that Q into sin alpha is equals to P, then find sin alpha into cos beta minus cos alpha into sin beta. Okay. So first of all, what is given? Q sin alpha is equals to P. From this sin alpha is equals to, if you send Q that side, hence sin alpha is equals to P by Q. Then consider a right angle triangle and let it be the angle alpha. Sin is nothing but ratio between opposite and hypotenuse. So opposite side is nothing but this side, let it be P. And hypotenuse is, this is the Q. Now we want to find the adjacent one. So adjacent one is nothing but hypotenuse square minus opposite whole square, which is square root of Q square minus P square. And I hope that you all know about Pythagoras theorem statement. So using the Pythagoras theorem, we can find out the adjacent side. Now from this, cos alpha is equals to adjacent by hypotenuse, that is root of q square minus p square by q. But here nowhere he mentioned about alpha and beta are belongs to which quadrant, because it based on that then sine and cos can be positive and can be negative. So this is the very important point, my dear. But he gave a hint that alpha and beta are complementary angles. Alpha and beta are complementary angles. What is meant by complementary angles? Two angles are said to be complementary if their sum is equals to 90 degrees. Isn't it? So that is what he given, that alpha and beta are complementary angles. I mean both together their sum is 90. Means these two individually below 90. Do you understand? So alpha and beta both are less than 90. I mean these angles comes under first quadrant. So you know that in first quadrant all the trigonometric ratios are positive, right? So that is why now sine alpha is positive, even cos alpha is also positive. Why? Because both together alpha plus beta is 90. So individually definitely alpha is less than 90 and beta is also less than 90. So no doubt that both angles comes under first quadrant. So now using the concept of complementary angles, alpha plus beta is equals to 90 and send any one that side. That is beta is equals to 90 minus alpha on sending this. Why? Because to enter into this, right now I know what is sine alpha and what is cos alpha. But I don't know what about cos beta value and sine beta value. So for that I want to take the help of this concept. Now apply cos on both sides. That is cos beta is equals to cos of 90 minus alpha. Cos of 90 minus alpha nothing but sine alpha. Because of 90 cos changes into sine and 90 minus theta is first quadrant, anyhow positive. Similarly if I take sine ratio on both sides, for this sine beta is equal to sine of 90 minus alpha, which is equals to cos alpha. So look at this magic here. Cos beta is nothing but sine alpha equals to sine alpha. And even sine beta is equals to cos alpha. Fine. So coming to the value, what is given that we need to find sine alpha into cos beta minus cos alpha into sine beta. I just want to replace these beta values. So sine alpha into cos beta. Cos beta just now we got it as sine alpha. So in the place of cos beta I can write it sine alpha minus cos alpha into sine beta. We just now got it, no? Sine beta is equals to cos alpha. So replace cos alpha. Now sine into sine, both angles are same and it is sine square alpha. Don't write sine square alpha square. Okay. Sine alpha into sine alpha, just like x into x, x square. That is sine alpha whole square can be written as sine square alpha. Minus cos into cos, cos square alpha. Just replace the value sine square alpha. Sine alpha is p by q. And its square nothing but p square by q square minus, what about cos alpha is this, and squaring of this one, no, cos square alpha. On squaring, numerator square root gets cancelled, hence q square minus p square by q square. Now look at the denominator is same here, q square. Hence directly you can add numerators, p square minus of q square minus p square. And you know my dear, before the bracket when there is a minus, then signs are going to be changed. If not, just multiply with minus. Minus q square, minus into minus plus p square whole divided by q square. So that is equals to p square plus p square, 2p square minus q square by q square. So this is the value of sine alpha into cos beta minus cos alpha into sine beta. So look at another beautiful question, that is number 8 from subjective 2. So prove that tan theta plus secant theta minus 1 whole divided by tan theta minus secant theta plus 1 is equals to 1 plus sin theta by cos theta. Most important question. So first of all, consider the left hand side, that is tan theta plus secant theta minus 1. In the place of 1, I want to replace an identity. Can you identify that what is the identity in tan and secant? In tan and secant, clearly secant square theta minus tan square theta. In the place of 1, I am replacing identity, that is secant square theta minus tan square theta. That too only in the numerator. Denominator I don't want to disturb. Okay. Now look at this. Tan plus secant is nothing but secant plus tan. Can write now? A plus B is nothing but B plus A. Fine. Minus. Now this is just like A square minus B square. Do you know? A square minus B square. How can we write? A plus B into A minus B. And whole divided by denominator is as it is. Do not disturb. No change. Right. Now this is common in first term and second term. This is secant plus tan is common. So let us take secant theta plus tan theta common. Then in the first term, after taking that common, leftover is only 1. And minus of secant theta minus tan theta. So let us multiply with minus this one. I mean minus secant theta and minus into minus plus tan theta whole divided by, see this is also, I just want to rearrange first 1 followed by minus secant theta and followed by plus tan theta. Nothing I did, just order changed. First I considered constant and then I want to write next term secant, which is minus, and then plus tan theta as usual. So now this term and this term getting cancelled. So what left with us? Secant theta plus tan theta. But we have to prove it as 1 plus sin theta by cos theta. Isn't it? Then you know secant theta can also express as 1 by cos theta and tan theta can be expressed as sin theta by cos theta. Right? Now denominators, you can observe that both are having same denominator. Hence LCM is cos theta. And when the denominators are same, can add the numerators directly. 1 plus sin theta by cos theta, which we need to prove. See, a simple technique. Only one technique is involving in this problem. That is 1, the numerator, whatever we have the 1, that should be replaced with the identity, that is secant square theta minus tan square theta. Later this is a square minus b square. I just want to write it as a plus b into a minus b. And then this term, plus term is common now here. That's what, let me take common. Then leftover is cancelled as it is. Especially denominator should not disturb. That is the technique in this problem. So some of the students, instead of denominator 1 also they may replace this. Then they may face a little bit problem while simplifying. So look at the another standard question, that is question number 9. Prove that 3 into sin x minus cos x whole power 4 plus sin x plus cos x whole square plus 4 into sin power 6x plus cos power 6x is equals to 13. So after simplifying this entire question, we need to say that answer is 13. The simplified answer for this is nothing but 13. So see how beautiful this question. Very easy. LHS. So first of all, I just want to write this as Sin x minus cos x whole power 4, we have no formula directly, isn't it? Anybody knows what is a minus b whole power 4? No. So that's why the technique is here. Better you can write like this. Whole square plus 6 into, this is you can write it directly, a plus b whole square, a square plus b square plus 2ab, that is 2 sin x into cos x plus 4 into, this is, let us write sin square x whole cube plus cos square x whole cube. Okay, sin square whole cube, which is nothing but sin power 6, cos square and whole cube, which is also cos power 6, because this is in the form of a power m whole power n, a to the power of mn, 2 into 3, which is 6. Fine. Now see the simplification, 3 into, this is a minus b whole square. What is a square plus b square minus 2ab, isn't it? Minus 2ab, 2 sin x into cos x, even there is one more square. Okay, now plus 6 into, this part sin square x plus cos square x is 1 plus 2 sin x into cos x. Fine, ma. Plus 4 into, a cube plus b cube. How can we write a cube plus b cube is equals to a plus b into a square minus ab plus b square. Fine. So a plus b, that is sin square x plus cos square x into a square, sin power 4x minus ab sin square x into cos square x plus cos power 4x, and this entirely should be multiplied with 4. So please do not confuse that. Okay, fine. Now you look at the next step, 3 into, once again this part is 1, no? Sin square plus cos square x is equals to 1. So 1 minus, this is 2 sin x into cos x entirely whole square plus, let us multiply this one with 6, 6 ones are 6 plus 6 into 2, 12 sin x cos x plus 4 into, first bracket value is 1 into, so look at this part, sin power 4 and cos power 4x. So this is, let me want to write sin square x whole square plus cos square x whole square minus sin square x into cos square x. Right? Please do not confuse and take care about the brackets especially. Fine. Now see, this is once again a minus b whole square. A square, which is 1, plus b square, square of this term, 2 square is 4, sin square x cos square x, a square plus b square, minus 2ab, no? So minus 2 into 2, minus 4 sin x into cos x. Fine. This bracket is closed. And followed by, there are 2 more terms, that is plus 6 and plus 12 sin x into cos x plus 4 into, so look at this part. What is this? This is in the form of a square plus b square. A square plus b square, I can write it as a plus b whole square minus 2ab. Fine, ma. So a plus b whole square, sin square x plus cos square x whole square, a plus b whole square minus 2 into ab. ab is nothing but sin square x into cos square x, and still there is minus sin square x cos square x. So see this, let me want to make it directly minus 3, because minus 2 and minus 1 together minus 3, and this is multiplied by 4. So please take care about the simplification. That is the only one matter. Yeah, please come on. Multiplication. 3 ones are 3 plus 12 sine square x and cos square x minus 12 sine x into cos x plus 6 plus 12 sine x into cos x plus, first bracket value 1. 1 square is again 1. 1 into 4 plus 4. And 4 into minus 3 minus 12 sine square x into cos square x. So see here, this term and this term both are cancelled. Even plus 12 sine square x into cos square x and minus 12 sine square x into cos square x also cancelled. Now 3 plus 6 plus 4. So together 13. So that is what we need to prove. Coming to problem number 10. Show that cos power 4 alpha plus 2 cos square alpha into 1 minus 1 by secant square alpha is equals to 1 minus sine power 4 alpha. So coming to the left hand side LHS, cos power 4 alpha plus 2 cos square alpha into 1 minus 1 by secant square. 1 by secant is nothing but cos. Then 1 by secant square is cos square alpha. Okay. Next, this is 1 minus cos square alpha is nothing but sine square alpha. So cos power 4 alpha plus 2 cos square alpha into sine square alpha. Okay. Now, there is a cos square alpha common in these two terms. So take cos square alpha common. Then out of cos power 4, after taking cos square alpha, still there is one more cos square alpha is left. So cos square alpha plus, so this term cos square alpha we took common, then the balance is 2 sine square alpha. Okay, now cos square alpha into, I just want to write cos square alpha as 1 minus sine square alpha. Isn't it? Cos square theta is equals to 1 minus sine square theta. Now, cos square alpha, I can write it as 1 minus sine square alpha. And 2 sine square alpha minus sine square alpha, which is plus sine square alpha. So you see, this is just like a plus b into a minus b. A square minus, this is everything b, no? B square. So 1 square is nothing but 1 minus sine square whole square is nothing but sine power 4 alpha, which is RHS. So just if you think about the fundamental concepts from trigonometry, we can solve the same problem even in other manner also, other model also. So why can't you try? You please try all the questions whatever I am discussing here in even other method also. Definitely you can solve. Hope you are all understood the concept what we discussed today and enjoyed a lot. Thank you. Thank you very much.